before I start, a quick show of hands. How many models do I have here? People who actually build models. So most of you. Okay, wonderful, wonderful. How many people know what is mean square error? Most of you. How many people know how to read income statement? Okay, different set of people, right? So that's the essence of what I'm going to talk about. And let's make this a family conversation. We have just a small group of people. We'll talk about how things happen, how they should, could they be done slightly differently. I have an agenda that is maybe two parts. The first part is a very sort of bird's eye view. And second part, for some of you might be very repetitive. First one is the slides. But then I promise it will become engaging. If you're into deep mathematics. And if you're not, pardon me. Because the session did get termed as how we incorporate business learnings, right? So modeling is a little bit mathematical, so I could not avoid doing that. So let's take example, for people who build models, and for everybody else also. Have you ever built an attrition model? A customer attrition model? I'll take example. If you have, just show me hand. If you are not, okay, nobody has. Have you built an income model? Okay, same process. Okay. So typically what happens when you build, for example, a attrition model, is you try to see how many people are going to not be with my business after, let's say, a certain period of time, called a year or so. Right? And basis certain calculations, you come up with a number, which is probability of customer leaving. And if that number is too high, you sort of assume that the customer is going to go. No, the customer that goes is not considered as a spectrum of modeling. That's a very sort of common business practice because we drive over decision based on what mean square error. Right? Now let us look at the business impact of building this attrition model. You call up a customer who is going to arrive. The customer said yes, the customer is going to go. So the model is working very well. So you decided that you'll spend some X amount of money to retain that customer. You send some goodies, you send some very common practice, right? What if you knew that this customer was never going to make you money anyways? You just wasted your money, right? And if it was the right set of customer that was going to attract and was going to make you a lot of money, then it's a rational decision. But all of this post-effect things are not incorporated in the modeling process overall. So, this is the agenda that we'll talk about, right? We'll talk about what are some of the business drivers of success for our organization. I will spend very little time on this. And then some of the questions that we generally ask as modelers or business folks. Business folks are not involved, they should get more involved in the modeling process overall. We'll talk about one specific aspect of model building, which is model training, and how do we incorporate business learnings into the model training process. So we'll talk about one specific thing called loss function, which is the integration point. Expected to be an integration point between modeling and business, but I have not come across a modeler who does that. There are research papers today who incorporate it, because we just assume model.fit fits the model, which is not correct. And I've been building models for lots of years. So it's very, very basic talk, not not the coolest thing, Gen AI, LLM and all, but basics never change. We'll talk about what are the properties and limitations of these loss functions. We'll also talk about how do you think about these loss functions and how do you actually change them to reflect the business. And we will take a couple of examples. We'll take examples of the separation model or income model, a couple of examples. But if you have any particular business problem in mind, you could also take that. I'll also talk about some of the research findings in this particular space. Most of the research papers in this space are only a couple of years old. So it's the next coolest thing. If you're not doing LLM, you should be doing this. And if you're doing LLM, you should know this still, because you don't know when that ends, right? So let's talk about business success. It's a fairly boring slide, right? So business is operated by very, very basic fundamental things, right? There is revenue, which is how much money did customers pay you overall, right? Then there is expense, which is how much money you burn in delivering whatever you delivered, and what is the income you get. Have you guys ever used any of these three numbers in any models? This crowd is very quiet. Some, right? But nobody really sort of after those numbers. Any reasons why? So the attempt that I'm making is I leave you with some very open questions. Right? Should they be part of model building process? Right? Similarly, cash flow. Right? There is cash flowing in, cash flowing out. Some of the biggest companies considered bank or Lehman Brothers went bankrupt because they could not manage their cash flows. But in our models, we typically do not consider cash flows. Right? Unless it's a collection model, where you're trying to collect money from the people, but then you don't take it the revenue. So we pretty much always ignore business fundamentals while building the models. And for that reason, I'll show you the research findings, but models typically 10 to 15% underperform. Just because modelers and business folks have not come to the same page. Because what modeling folks will talk will be completely integrated with maths, and what business folks will believe is that they're modelers. Right? And this is a sort of chicken and egg problem, right? So I have some past experience, and I see my friend Ayush here, I solved this problem a number of times, and some of the models that I've built in past are in production delivering good value. In fact, one of them was with Ayush, if you recall. So I will encourage all of you to try to communicate more closely with your businesses to see how you can work very closely with them. So the expectations from businesses, when they either replace the older model or build a completely net new model into some process flow, would be that you are able to predict accurately some business outcome. And the key here is not accuracy. Key here is business outcome, which is what we generally use. Typically, you would see models with 90% ROC, very good burn ratio, very good accuracy, very good mail, very good whatever, where you find a math measure, it is look very good for every single model I've ever seen. But very few models deliver the business value that they should. So what ends up happening? You have model followed by a large set of rules, which make sure that the model is able to work. And those rules keep changing. Right? And how do you solve for it is, you change your model building process so that those rules are almost always never period. There would still be some changes to the business environment and all, which will make it necessary. So there should be ability to do it, but your model building process misses a lot. Right? So there is always an expectation of stability and efficiency. But the you guys are okay if I keep moving. Okay. So there is, yes. No, we are not talking about anything different. The risk models are so the question is, risk models do incorporate affordability and income and that kind of things. So we are talking anything different. We are not talking anything different. What is the objective of risk models? Right. Do we include that? The cash flow? No, do we include that cash flow? Let's say you're building a PD model, and I know most of you might not. We can have a separate discussion on this particular topic. I come from the risk modeling domain itself. So we do incorporate some information, but not all of it. So we can talk about the loss functions because mean square error is not a risk function, right? Neither is MAP. None of those drivers, like we generally think, neither is log loss. You would generally build like many of these models using log loss as the loss function. It is not incorporated, most of these things. Right? Scalability and efficiency goes without saying. You expect that model will scale for a business problem. If it is like real-time fraud detection, like a model does include that. There is interpretability, which is becoming lesser and lesser, but there are techniques which people are using. So business expectation is that you'll be able to explain whatever is being done using some sort of business judgment. Sometimes possible, sometimes not so. Cost efficiency, as you move on to cloud, that is becoming more and more important. So for the people who already work in organizations that use cloud, you would know, that you have to every time you train a model, you have to mention how much value the compute will take. Okay. So there is always that cost benefit analysis that is also expected that you'll be able to do, and consistency definitely. If you are telling one customer is a good customer today, if I score again 4 hours later, the customer should still stay good, right? It should not be flip-flopping. So these are some of the drivers of business success. Let's look at some of the questions that modelers do ask, right? And I'm not going to too much detail. Obviously, people will ask about what is the objective, what is the value of this model has, what are the data requirements that are for this model, and in case the data has some goofy thing how do you sort of impute it, etc. We'll talk about feasibility, right? Whether I have infrastructure, I need bigger server, I need cleaner data, I need more data. That will be a very important thing. And stakeholder impact, which is a very good thing, right? Who are the key stakeholders? Who are the internal people who get touched? Is it my marketing team? Is it my risk team? Is it my finance team? My external stakeholders, customers, etc. So these are some of the things that people will generally ask. Right? But let me also ask, how many modelers have thought through what are the new risks you are getting exposed to by using the model? Have you guys ever thought through that? Once you put a model, it is expected to replace something that is already running. Not only data driven, in the business process also. Right? So coming back to the attrition model, if we lose a high value customer, that's a big business risk. Right? So your modeling error has a real revenue risk. Right? So that could be one type of risk. Data drift definitely you monitor for. Right? But people generally don't think about monitoring either. Right? So what I've generally seen is people pay very little heed to the risk management aspect of model, because modeling does expose a business to new types of risk. Some of these risks are manageable. Some of these risks can be mitigated through better model development process, and some of these risks have to be taken. That's the business reality. But I think it's very important for modelers to think through what are these types of risks and how do you sort of cover for them. So scalability is one more thing, right? Do we actually know what will be the target scenario, what is the business expansion plan, right? What is the scale that we're going to get at, and how do we provision as we scale, right? Do we need several instances of this model running a separate infrastructure, etc.? So those are important things. Maintenance and monitoring, as you mentioned. Right? Very few people ever, during their model development process, think through what that this model is going to be monitored. So one of the best practices around that is you actually save the data on which you're developing the model. So you can always benchmark it forward. In some industries it is regulated. In many industries it is not. So where it is not regulated, people hardly think about monitoring in a very standardized fashion. Cost benefit analysis. This is where we talk about, is there a good replacement for this model? Do I actually need this model, first of all? And if I do, what is the value expectation that I have from this model? When do I actually throw this model away? When it's not delivering enough value, or when do I retrain, right? All of this cannot be only based on data drift. It has to be based on business fundamentals. So this is not a one-time process, rather it has to be a continuous process, where we keep looking for alternatives as well as keep evaluating how much value I'm getting out of the business. And next is ethics. Guys, let's be real. There is a lot of information available, on internet, on wherever, on your mobile, and pretty much all of this information could either be bought on dark web or taken with your consent. Okay? But I think as modelers, we need to be very ethical about how we use. I was just talking to Cyrus Doja, he was in the guest speakers room, and one the conversation that we had was where do you sort of draw the boundary of ethics? Right? Is machines taking over okay, right? And how far are we from that scenario? So I shared the bad news with him, that it is possible. The only constraint right now is the data system, right? Otherwise, I guess technically, we could have machines working 24 hours and humans working 8 hours and closing that gap day after day. Okay? So we need to be very ethical about how we build models, what we build models for, and we also need to be aware of the regulatory side of things, right? So the industries that are regulated, some of the industries that are not also regulated should look at the regulations that their customers are exposed to. Because eventually models are going to deliver outcomes for the customers of the model building company, if you work for a model building company, right? Or internal customers. So, any questions so far? Because this was my high level yarn section.
Excellent. There is ROI, right? So
right.
also, actually, it becomes difficult to quantify the ROI because it is analysis observation of the existing process or the service pipeline or whatever. And some models are actually, we are able to quantify the ROI. So where it is difficult to, quantify the ROI, what's the right choice or right direction we can take?
So you're right. So the question is, it might be very difficult to calculate ROI for every single model. How do we make sure that we're able to measure the business benefits of every model? Right? See, what businesses expect you to do is not to directly deliver from every single model anything that they measure on interest rate. All you can impact is a driver of that. So for example, let us say, for going back to the example of attrition, let us say customer servicing is one aspect for which you have built a model. It will be very much possible for you to see if there is 1% change in customer serviceability, how does it impact the revenue or how does it impact the retention? And that's how you measure it. Will it be approximate? Yes. It will not be perfect? Yes. But will it be better than what we are doing today? Absolutely yes.
Sometimes it happens because the real actual value, it takes a time to generate, right?
Absolutely.
So 6 months or 1 year.
Yes.
So in that, most of the time it happens that business is not seeing the value and they stop using it. And I can see this. So how can you mitigate that?
Yeah. No. So there has to be a sort. So we can talk about how do you sell it to business, right? But there has to be a concerted effort. Let me just put it that way. There has to be effort. Yes, there do businesses get on what they want? No. But if you involve them in the model building process, they become participants with you of the model, right? And then they co-own with you the outcomes. And I know it's not a straight answer. There is no sort of magic wand that you can put on your customer and have them with you. Any other questions so far? Yeah.
What about the data volume required for these analysis? Like, I can understand in an application model you will have millions of records and customers. From a patient or from pharma side, we operate in thousands of records and we track thousands of patients. So I will not have the luxury to include multiple other filters or these kind of ideas through my models.
Yeah. See, pharma is a very interesting industry. Right? So if you think about customers, let's say I'm a bank and I lose some money, it's okay. But in pharma, losing patients is not a very good thing, right? So business expectations from model are very, very different, right? So in that case, my cost benefit is not only about dollars, right? My cost benefit is includes patient impact. How do I weigh patient impact in my decision making process is what I need to think. So guys, everything I'm talking about, right? Please take everything with a grain of salt because you need to customize it for the industry that you're looking at and the business outcome you are looking at. Right? If you go to, for example, a pharma company and say, hey, I have this dollar chart, by the way, you're going to lose 25% of a patient to undergo trials, then that's not fun at all. Any other questions so far? Yes.
So it's kind of a follow-up question to his one. So when in a case the investment from customer service impact will take some time to get in, say.
Yes.
But similarly, I want to see on the investment and ROI part of it. And exactly again going to the first point when I have to include the revenue, but it's not easy to attribute the revenue in for perfect level.
Yeah.
And it's a kind of again what to start with, what to end with.
See, for customer satisfaction, you have things like NPS score you could use. I'm sure every organization has some measures they include, and you could see impact on those a lot sooner, right? So how do you bring that into revenue or efficiency number is something that you have to do for that particular industry.
Exactly, we started with NPS. NPS also takes around 6 to 9 months to
We can
show some.
we can talk of your specific scenario, okay? But the end outcome is you have to relate it to business outcome somehow. Unless your model output links to the business outcome, I'm sorry to say your model is not delivering any value at all. And that's what you have to do because it's your model. And most models don't do it. And then they complain the businesses don't use it. So that's the reason I talked about all this. In fact, I enjoy talking about the second part a lot more, which is the model building process. So you guys, I guess most of you know this, right? Models have a very sort of standard high-level approach in which they are built, right? Points to notice. Number one, none of them has anything that starts with business or ends with business, other than the objective and implementation, right? The problem definition and implementation. So in the process, we do not engage with business, right? Number two, to notice that that little guy. So that is created with GenAI. I wanted to make my presentation cool also. So I'm not going to talk about all of it. I will talk about only one step, which is model training. Because I think the rest of these things are happening very well, right? Enough engineering companies are working in this particular space. Problem definition you have to figure out in your industry. After that, the way the life works in modelers is, once all of these are done, we typically start around here on the data screen, right? We create some feature, we think they will work. Sometimes we talk to business and say, hey, how about if I divide this number by this number, does it make sense to you? They say, okay, we are fine. That's the level of discussion we'll have with business. Then after that, we'll go and say, hey, actually who's sort of the school? Let me look at the CNN, let me look at it or whatever. Some model structure and train it. And once it is trained, it is going to give the outcome. Right? So the outcome comes, we evaluate, right? Let's say it's 90%. Like an ROC 90% or GDF, whatever. Some good number. Right? And once we are happy, we'll show some numbers to our IT team and business team and get the model implemented. That's how typical life cycle will work. There is something that happens in model training which makes you talk about it. During the model training process, what happens is consider model training as a teacher. Okay? Model training will ask, let's say role play, between you and me. Right? Let's say I'm the teacher. I'll give you a test and you give me the result, I'll mark it. Let's say you get 5 out of 10. I look at the chapters you did wrong and I ask you to read one chapter. You read it again and I give you test again. Right? So this process keeps repeating till his like your score reaches, let's say, 90% level. And then you say, oh, he is learned enough, so he is a good model now. Right? So this process is called model training. But during this process, the process in which I am determining what he needs to learn is called loss function. Are you guys with me? What is the loss function? So, like if you take any sort of machine learning work or artificial intelligence work, you would see this picture a lot, right? It might look like this, or it might look like a sort of a U, and somebody sort of running down the U, right? So the beauty of this picture is, that you can, if you put a ball somewhere, it will roll down to the bottom, right? That we call the minimum loss or minimum error thing, right? So most loss functions optimize in a way so that you reach a minimum of error, and that's the point at which we call model string. So everybody understands what loss function is, because the rest of the discussion is going to be about loss function. Okay. So typically for models which are let's say some tree-based models, XGBoost or regression-based models, this process of going down is called gradient descent. The same gradient descent approach is fed into neural nets in shape of something called backpropagation. Right? So this loss function is a very good way to integrate with the business approach. I'll tell you the reason why. Currently, we are optimizing for mean square error, and what that means is, in my result, as far as the total mean square error is the least, I am happy with the model that I get out of it. Now, if I train my model on minimizing income errors, then what it would mean is the income value I get is right. If I do it on expenses, then it will be expensing is right? So those are the outcomes that businesses are looking for. Now the key question is we never have. I don't build a model to predict. There are hundreds of drivers, but I don't build a model to predict expenses. There are hundreds of drivers to predict, etc. Right? So how do we link this loss function back to the business outcomes? And that's a problem that you need to take, right? But this loss function is the point of integration, the business problem. And loss functions do have several properties. So the first property of the loss function that I want to talk about is simplicity, which is let's say in the pharma industry, somebody unhealthy came to a hospital. His health worsens 10% or betters 10% are considered equal outcomes. Are they? They're not, right? Similarly, 10% more customers get writing or 10% less customers get writing is considered equal outcome. Right? So that is the nature of the loss functions we train, which is one of the key reasons why our models don't perform as the way we expect them to. The second, key to these loss functions is their interpretability. But this is interpretability by statisticians. This is not business interpretability. So businesses, in fact, do not even know that there is something called loss function on which you are optimizing. Okay. The third, obviously, is business agnostic. It's both good and bad. Good in terms of you can do it anywhere. Bad in terms of it does not deliver the business outcome that you require. And the fourth mathematical property of these functions is differentiability. So these functions are differentiable twice. So if you guys remember your class in functions that you might have taken, first level differentiability is called slope, and second differentiability is called Hessian or double derivative, whatever you call it. Okay. So all the functions need to exhibit these properties for them to be used as loss functions for your machine learning training. Okay. Any questions so far? So please stop me whenever you have questions. Go ahead.
modeling point of view?
Can you take the mic for people? Can't hear it.
N number of factors, which are highly correlated with each other, but somehow or other, and like a client wants to, get this variable in the model. So how do we mitigate those kind of scenarios? Because see, at the same time we are trying to minimize the cost function and get a better output, but at the same time we have to understand the client need also. And this is one of the very classic examples of what we often facing, as model analysis.
See, unfortunately, what happens is, I'll give you two answers to that question. The first answer is, unfortunately, people do carry a lot of baggage with them, right? So sometimes you will come across clients who believe in certain thing and they will ask you to include certain facts. So in those cases, it's very good to have some analysis around why that variable makes sense or not, right? You cannot discount their intelligence either, right? So that's the first answer. The second answer is what you see in windshield versus what you see in rear view mirror is typically not the same. It's practically always not the same, right? So sometimes businesses do have a direction in which they want to go, and their data may not actually capture it. So it really depends, on what is their go forward strategy. So the reality is what we do in modeling, right? We look at history and we say, hey, future is going to look like this. That's not reality. We know it is wrong by design. Right? Future is going to be different. The business environment is going to be different. The strategy is going to be different. So we have to understand their strategy. If we don't, the business will start with very less usage of the model and it will degrade a lot faster because the population you get in future will be very, very different. So it's the right answer is in middle of this. Okay, and no more questions? Let's move on. So, I think I've talked briefly on these limitations, of all these loss functions. The first is that we call errors equally. To example of pharma, we could take several more examples, let's say income, the model that I should for a lender, predicting somebody's income higher than what it is a very risky thing. Whereas predicting it a little bit lesser is losing some opportunity cost. Real money and opportunity cost are two very different things. They can't be valued similarly. Okay. The second is the lack of focus on business objectives. Right? So these models don't really care what your impact on profit is going to be, and you need to somehow incorporate how outcomes are very different in these cost functions. And third, miscellaneous incentives, pharma example. In some industry, it's absolutely wrong to be wrong. Right? So we need to make sure that the incentives that we are giving to our model, which means lesser penalty, is for the right type of customers. So I've taken a few more examples, right? So I think we have talked about this example, but just for the math in you, let us say you operate a business in which the churn rate is 10%. What will be, and my model, I'll give you a model. I predict everybody as no churn. What is accuracy of this model? 90%. Right? I have not even seen your data. Just by knowing that you have 10% churn, my model has 90% accuracy. Right? So just relying on numbers like accuracy is not sufficient. We need to be more dependent on what is the business outcome we want. Right? I've written some things here. Where I talk about customer value needs to be seen along the direction. So just just to make sure that you guys are still with me, what would be a good loss structure to have in this scenario? Business reality, right? You would never want an equal weightage to those customers. Any takers? Sure. Let's assume history repeats, right? So that's the assumption that entire modeling space has. In fact, in many geographies, it is not even permitted to adjust anything that data throws.
I guess F1 score.
F1 score, you said. Okay.
Binary loss.
Loss function, right?
Logos.
Loss is binary
Binary
cross.
Okay. So how do F1 ratio or the binary entropy, they incorporate value of the customer?
F1 is for evaluation, right?
Yeah.
Loss function is for minimizing and optimizing.
Sure. No, but this loss function that we're talking about,
Mm-hmm.
whatever nature of this is, see, we did not hear the term customer value, right, or customer revenue. Do you think that is important?
Yes.
Your loss function does not include it.
Alright.
Okay.
You were trying to QED distribution.
Doing the augmentation for the high
QED
revenue
distribution.
customers.
Doing the augmentation for the high revenue customers separately?
Sure. We could build it as a separate segment. That's one way.
Hello?
Yeah.
We can weigh down the log loss on user items. So basically when we compute log loss for every line, that time we can put the weight of high customer.
Okay. So you will multiply the log loss
With
by
that,
the expected revenue. Let's call it log revenue.
right.
Yeah, that will work. That will work. So all I'm asking you guys to do is something as simple as that. Take the loss function, multiply it with business value. That matters. And the outcomes are great. So here I take an example of this income. Right? So I've done this one for you. What we have done is we have taken the errors, and wherever there is overprediction happening, which we don't want to happen, we have just multiplied by 2. Very sort of simplistic, sort of creating an asymmetric loss curve, which is more aligned with business than our traditional methodology that we use for machine learning. Correct? Let's look at what does research say, on this particular topic. Sorry, I put Ayush and me there. I predicted Ayush will be there. So, in fraud detection space, if you use a right asymmetric loss function, the research shows that you have 45% less false negatives. The biggest problem in fraud detection is false negatives, in case you don't do that. Similarly, for e-commerce, there is 15% lift that you get if you give profitability by similar customers as part of your loss function. And by the way, all of these papers are available on Google. Just that nobody looks them up because we believe you know how to fit them out. Then in the space of risk function, there is a 10% improvement that you can get in NPL. The loss is non-performing loans if you use right type of function. And in pricing, you typically get 7% improvement by using these models. So do you guys think it makes sense to multiply a number by whatever that outcome is? It's not as simple as that. There is you have to also calculate first derivative and second derivative, which I'm sure you all know how to do. Or you can Google it. There are enough Kaggle competitions. In fact, it is being used in Kaggle only twice as of now. So I looked up 2 Kaggle competitions. Competitors have used it so far, both won. And there are 4 research papers in this space. So it's a new upcoming area, but I think the coolest area to work in if you are a traditional modeler. And I'm sure this can be incorporated in LLMs also, because LLMs do use context vectors to create your RAG model. Currently, that RAG model is business agnostic. It smells right. Why should it be business agnostic? I run a real business with my real business reality. I don't want anything business outside. Like if I'm going to run something real in my business, in which with which I'm going to make real decisions, it's better know my business, right? Okay. It will not be complete without this. Right? So you may build a model which is very good, which may have the right loss function and everything right about the model building process. It will still not replace the decision making. That needs to happen outside of the model. There are several reasons for that. I try to put top three that came to my mind. The first one is model may know what I did in the past. Model does not know what I need to do in the future ever. Right? And model may not be completely context aware. Even with LLM, it will never become completely context aware because there are things like new competitors coming in the space. There are things like changing pricing strategies. There are things like changing operating models. Businesses models will never be aware of that. Second is the data-driven insights. Right? So a lot of data goes into the model, but not all of it goes into the model. Right? So there might be insights that other analysts might throw. Basically, you might want to make a decision different from what model predicts, and then model has no ability to see what has not happened before. For example, you operate in some earthquake from area earthquake happened. What do you do? Right? It has not happened in the last 5 years of data that you're using for your model, etc. Right? So in my view, models are never going to replace humans when it comes to decision making. So in conclusion, I believe we all need to be more comprehensive, working with our businesses during the model building process. We need to ask both the leading questions about the risks that we're exposing to the business by building a model, the regulatory implications, the scaling implications, etc. during the model building process. Second, we need to tailor our loss functions during the model training process to be closely aligned with what is the objective of the model. And I do believe as our processes and models integrate more closely, you see how many people are here in this whole conference, right? It will become very, very critical that models align with businesses and the people who do will win the game. So that's it from my side. If you guys have any questions, happy to take. Thank you. No?
What are the papers you will refer to the papers? Prominent journals. What are the prominent journals?
I can share the details with you. Because I didn't find it appropriate to put them on the slide. Because I did look them up through Google. So there were all different journals. There was a paper by a guy with last name Zhu that I showed you. There was another paper from Lucerne University, Switzerland. So there were various different papers. I can give you the reference for one. There were 4 papers.
Puneet, I will share a quick question.
Yeah.
I think you spoke about loss functions a lot, but how about reward functions? What's your view on models that look for reward instead of loss?
Yeah. See, reward is nothing but one man's loss, right? Yeah.
The way you train the model, you also reward it for something it does good.
Yeah, less penalty is reward.
Yeah.
Less penalty is reward.
So ultimately, you say it's still about the loss function.
It's still about the loss function, right? You have to either minimize or maximize the function. Unfortunately, the literature is much more heavy in the functions like differentiation, get you towards that loss. Could you integrate and go towards reward? Possibly, but that's not how we are doing it today. Maybe we can write a paper on that. Yes, actually, after.
So, sir, you talked about the constant model refresh, right? Constant model refresh because there are many times the data is such
Absolutely.
So what should be the minimum time period, let's say if I build a model file. So for the reference, is there a minimum time that what we should provide it?
See, in my view, you should always have a evergreen strategy for the model. And what I mean by that is, if you were to think of traffic lights, right, there's green signal, amber signal, and red signal, right? Your model should always be in a performance area, which is good, right? There could be several drivers of integration. The first driver could be that underlying data does not capture business reality anymore. Number two, data has shifted very significantly. Number three, rebuild could deliver a lot of value, right? So one needs to evaluate all of these together to determine whether the model is in that green area or not. But there is no such frequency on which I'll say that all models need to be refreshed. Like, for example, if you look at Amazon, they retrain a model every 1.5 minutes. You look at some of the banks, they retrain every 4 years. Right? So depending on the business, depending on the impact, and depending on the change in competitive environment and how well data captures the reality, you will need to decide, like, what frequency is the right for your industry. What industry are you from?
So
Retail. I've seen like people do it every year. You guys have no explainability requirement, no difficult governance. I've seen people do it every month.